Okay, so the next video is the additional problems here at the transcendental functions. So we will be dealing most likely with ln, e to the u, and a to the u. So let's start with number 1. We have the integral of the quantity 1 plus 2 ln x, quantity raised to the power of 4 dx all over with x. Now definitely we will be choosing this one as the u. We have 1 plus 2 ln of x. The derivative of our u, the derivative of 1 is 0, plus copy 2. The derivative of ln x is dx whole over with x. Okay. So if you look at the problem, we already have dx and we already have x for the denominator. We only need 2. So multiplying with 2 over 2, integral of 1 plus 2 ln of x raised to the power of 4 dx over x. Writing the numerator 2 inside, replacing it with 1. So we now have 1 half integral of u raised to the power of 4, and obviously this is the du. Okay, so power rule, u raised to the power of 4, that is equivalent to u raised to the power of 5 whole over with 5 plus c. 1 half times 1/5, we have 1 over 10, u raised to the power of 5. Now the final answer will be 1 over 10. The u is 1 plus 2 ln of x plus c. Now for number 2, we will be evaluating the integral of x squared ln of 1 plus x cubed raised to the power of 3 all over with 1 over x cubed. We will be choosing this one as the u, ln of 1 plus x cubed. The derivative of ln u, copy 1 plus x cubed for the denominator, derive this one. The derivative of 1 is 0. The derivative of x cubed, 3x squared dx. Now let's try to check at the given problem. We have dx for the numerator. We have x squared in the numerator. And we have 1 plus x cubed for the denominator. We only need 3. So we'll be multiplying this one with 3 over 3. Integral of ln cubed 1 plus x cubed x squared dx whole over with 1 plus x cubed. Writing the numerator 3 inside, replacing it with 1. We now have integral of u raised to the power of 3. This one is obviously the du. Now let's solve. 1/3 u raised to the power of 3, that is u raised to the power of 4 all over with 4 plus c. 1/3 times 1/4, we have 1 over 12 u raised to the power of 4 plus c. Let's bring back what is the value of u. So now 1 half ln of 1 plus x cubed plus c. Number 3, let's try to find the relationship between the inside function and the outside function. So if we choose this one as the u, 4 minus e raised to the power of x, the derivative of the u, the derivative of 4 is 0. And we have minus the derivative of e raised to the power of x, that is e raised to the power of x dx. Looking back at our original function, we have the dx right here. We have the ex. We only need -1 to supply for the du. -1 whole over with -1 integral of quantity 4 minus e raised to the power of x raised to the power of 2/3. And we have e raised to the power of x dx. Now writing this negative 1 inside, placing with a positive 1. So negative 1 over 1, so this is negative. The integral of this is the u raised to the power of 2/3, and this one will be the du. So we have integral of u raised to the power of 2/3, that is u raised to the power of 5/3 over 5/3 plus c. Now we shall have negative. Take the reciprocal of 5 over 3, that is 3 over 5 u raised to the power of 5/3 plus c. So now we have negative 3/5 the u as 4 minus e raised to the power of x raised to the power of 5/3 plus c as our final answer. Now let's continue with problem number 4. The integral of the quantity 1 plus e raised to the power of 2y, quantity raised to the power of 1/2 dy whole over with e raised to the power of 2y. Now, if we are going to evaluate this type of problem first, let's try to again find the relationship between numerator and denominator. So if this is our numerator, 1 plus e raised to the power of 2y, is this the derivative? Since we have negative 2y right here, how about writing the inverse of this one? So taking the inverse of e raised to the power of 2y, e raised to the power of negative 2y dy. Okay? Now, we can choose this one as du. 1 plus e raised to the power of negative 2y. The derivative of that, the derivative of 1 is 0. The derivative of e raised to the power of negative 2y, that is e raised to the power of negative 2y. The derivative of the u, the derivative of negative 2y, that is negative 2 dy. If we look at here, we need negative 2. So again, with completing negative 2 over negative 2, quantity 1 plus e raised to the power of negative 2y raised to the power of 1/2 e raised to the power of negative 2y dy. Writing negative 2 inside, this will become 1. So now this is the form of negative 1/2 u raised to the power of 1/2, and this one is obviously the du. As negative 1/2 u raised to the power of 3/2 over 3/2 plus c. Okay, so canceling negative 1/2, and we have 2. So we now have the result of negative 1/3. The u is 1 plus e raised to the power of negative 2y raised to the power of 3/2 plus c. Our final answer. Now solving number 5. Number 5, we have the integral of quantity 1 minus 2x, quantity raised to the power of 2 dx over x. Now if we choose this one as our u, then this right here will not be our du. What would happen to the denominator x? So this type of problem, we will be first expanding this quantity raised to the power of 2. Okay, so this is equivalent to 1 minus 4x plus 4x squared dx over x. We could distribute the or split the x to all our terms for the numerator. So let's have okay. 1 over x minus 4 plus 4x, and everything is quantity multiplied with dx. So now let's proceed. We could have integral of dx over x minus 4 integral of dx plus 4 integral of x dx. Integral of dx over x, that is ln x, minus 4 integral of dx, that is x, plus 4 integral of x dx, that is x squared over 2 plus c. So we now have ln x minus 4x plus, so we now have 2x squared plus c as our final answer. Now for problem number 6, we have the integral of the quantity u squared plus 1 quantity raised to 2 du over u cubed. Okay, first, if we select this one again as our u squared plus 1, deriving this one, this is not the du, and what would happen to the u cube from the denominator? So the process that we're going to do is to expand first this quantity. Okay, so we now have u to the fourth plus 2u squared plus 1 du all over with u cubed. Okay, the next thing is that we will try to split our denominator to all of the terms in our numerator. So we now have u to the fourth over u cubed plus 2u squared over u cubed plus we have 1 over u cubed. Everything is multiplied to du. So now, okay, so now we have the integral of u plus 2 over u plus 1 over u cubed times du. Distributing the integral symbol and the du, integral of u du plus 2 integral of du over u plus integral of du over u cubed. Okay, so now we have u du as u squared over 2 plus 2 ln u plus, here we could rewrite this one as u negative 3 du. So now let's solve problem number 7. We have the integral of v plus 3 over v minus 1 dv. There are many ways in how are we going to solve number 7. Let's start with the first one. Okay, notice we could simplify this fraction. If we're going to divide v plus 3 with v minus 1, so we'll be needing 1 v minus 1. Subtracting this one, we have a remainder of 4. So plus 4 over v minus 1. So rewriting this fractional form of 1 plus 4 over v minus 1 dv. Distributing the integral symbol and our dv, integral of dv plus 4 integral of dv over v minus 1. Okay, so now let's evaluate the integral of dv, that is v plus 4 integral of dv over v minus 1. If we choose the denominator as the u, v minus 1, the du is dv. So the form of du over u, that is ln of the u, or ln of v minus 1 plus c. This will be our final answer with the use of algebraic method. How about for transforming number 7 in terms of u? So we could transform if we have choose the denominator v minus 1 as the u, the du will be dv. We could replace the value of v as u plus 1. Okay? So, substituting this one to our original problem, we have the integral of the v here, which is u plus 1 plus 3 all over with v minus 1 is the u dv. U plus 4 over u dv. We could split the denominator to both our terms. So we now have u over u plus 4 over u dv. The u over u, that is 1. And we now have 4 over u. Distributing the dv, integral of dv plus 4. The dv is actually equivalent to du. So this one are all du. And distributing our du and the integral symbol, we have du plus 4 integral of du over u. So the integral of du, that is u plus 4 ln of u plus c. Now u is originally v minus 1 plus 4 ln of v minus 1 plus c. Now if you look at this method, why is it that we have minus 1 here and the previous one we don't have minus 1? Minus 1 is a constant added to the constant. So we could erase this one. Okay, so minus 1 plus c, it will still become c. So we now have v plus 4 ln of v minus 1 is still the same answer with our previous solution. Okay. Now for number 8, we have the integral of r quantity r squared minus 1 over r squared plus 1 dr. So what shall we do is first we will be distributing the r. So this will become r cubed minus r over r squared plus 1 dr. Now if we look at our fraction, we have an improper fraction. On our previous video, we tried to simplify this one first by dividing. We have r cubed, we have plus 0 for the r squared, minus r plus 0 for the constant, divided with r squared plus 1. So we shall multiply with r to have r cubed, and we have plus r. Subtracting this one, cancel, this will become negative 2r plus 0. So we will be having a remainder negative 2r over r squared plus 1. So replacing this fraction into this term right here, so we now have the integral of r minus 2r over r squared plus 1 dr. Okay, distributing our integral symbol, integral of r dr minus 2 integral of r dr over r squared plus 1. Now notice, if we choose the denominator as the u, r squared plus 1, the du, it will be 2r dr. So let's write the 2 inside. Okay, u denominator and du as the numerator. So we now have integral of r dr minus integral of du over u. r dr, that is r squared over 2, minus d over u, that is ln of u plus c. What is our original value of the u? We have r squared plus 1 plus c. This will be our final answer. Now number 9, we have the integral of e raised to the power of 2t plus e raised to the power of negative 2t over e raised to the power of 2t minus e raised to the power of negative 2t dt. If we choose the denominator as du, e raised to the power of 2t minus e raised to the power of negative 2t, what will be the du? The derivative of e raised to the power of 2t, copy, e raised to the power of 2t, the derivative of 2t, that is 2 dt, minus, again with copy, e raised to the power of negative 2t, the derivative of this one is negative 2 dt. Now simplifying du, that will become 2 e raised to the power of 2t dt minus e raised to the power of negative 2t now the du, it will become 2 e raised to the power of 2t dt, negative negative, so we have positive 2 e raised to the power of negative 2t dt. Let's simplify this one more, factoring out 2 and the dt, e raised to the power of 2t plus e raised to the power of negative 2t times dt. If we look at our original integrand, we have e raised to the power of 2t plus e raised to the power of negative 2t dt. We need 2. So we have to multiply 2 over 2, integral of e raised to the power of 2t plus e raised to the power of negative 2t, all over with e 2t minus e negative 2t dt. Writing this 2 inside and replacing it with 1. We now have 1/2 integral of du, this one, du, whole over with the u. So that is 1/2 ln of the u. 1/2 the ln, the u is previously equivalent to e raised to the power of 2t minus e raised to the power of negative 2t plus c. For number 10, we have the integral of x plus 6 whole over with x plus 2 quantity raised to 2d of x. Okay, this type of example, we will be needing another technique. No matter what we do, choosing this one as the u, deriving this one, this will not become the du. We will try to extract 2 from 6. So we will be rewriting this one as x plus 2 plus 4 whole over with x plus 2 squared d of x. Okay, so that we could split this one, we could rewrite this one as the integral of quantity x plus 2 whole over with x plus 2 squared. We have our plus 4 dx. So in this case, we have 2 terms for the numerator. Let's split the denominator to both of the terms. Integral of x plus 2 over x plus 2 squared plus 4 over x plus 2 squared dx. Notice we could cancel one value. So this one will become 1 over x plus 2 plus, how about this one? We have 4 over x plus 2 squared dx. Distributing the integral symbol and the dx, we now have the first one as dx over x plus 2 plus the 4 is constant, 4 integral of dx over quantity x plus 2 squared. Okay, if this one is the u, x plus 2, the du is dx. If this one is the u, x plus 2 again, the du is obviously dx. So this one is the form of du over u plus 4 integral of du over u squared. We could rewrite this one. Integral of du over u plus 4 u negative 2 du. Okay. This one is ln of the u plus 4. How about this one? Negative 2 plus 1 is negative 1 over negative 1 plus c. Ln of the u plus, so this is no longer plus because we have negative for the denominator, minus 4 over u plus c. Because this one is negative exponent, so trying to take the inverse. So we now have ln, the u is originally equivalent to x plus 2 minus 4 over x plus 2 plus c. Now solving for number 11, the integral of dx over x, quantity 1 plus x squared. Previously, we have different techniques in solving this type of problem. So solving this one, we will try again the previous method that we have used. How about correcting the numerator in order for us to have the same value in our denominator? So this could be rewritten as 1 over x, 1 plus x squared dx. To have 1 plus x squared, we already have 1. If we add x squared, we have to subtract x squared, right? To have a still value 0. Okay. We could now group this one, these two terms. 1 plus x squared minus x squared all over with x quantity 1 plus x squared dx. Now we could split our denominator to both terms in our numerator. Now have integral of 1 plus x squared over x 1 plus x squared minus x squared over x 1 plus x squared dx. We can cancel 1 plus x squared. We can cancel 1x and our x for the denominator. So we now have, let's do not forget the parenthesis, integral of 1 over x minus x over 1 plus x squared dx. Distributing the integral symbol on our dx, integral of dx over x minus integral of x dx over 1 plus x squared. If this one is our u, this one is obviously the du. If this one is our u, the du should be derivative of 1, 0, x squared, that is 2x dx. We already have dx, we already have x, we need 2. So we now have integral of du over u, and we will correct that one with minus 2 over 2, integral of x dx over 1 plus x squared. Writing the 2 inside, replacing it with 1. So the integral of du over u minus 1/2 integral of du over u. Du over u, that is ln u minus 1/2 ln of u plus c. What is the u here? We have x. Ln x minus 1/2 ln of, how about this part right here? We have 1 plus x squared plus c. Our final answer. So for number 12, we have the integral of tangent x dx. We don't have an immediate equivalent for tangent x dx from our previous formulas, even from the derivative, because the derivative of tangent, that is secant squared. We don't have secant squared here. So what are we going to do is that we will try to find the equivalent identity for tangent x. What is the equivalent identity of tangent x? Since this is not squared, we could use the ratio. Tangent is the ratio of sine x over cosine x. And we have the dx right here. If we choose cosine as du, the du should be negative sine x, and the derivative of x is dx. Okay, so we will be needing negative right here. So we replace negative and negative. Negative integral of, this is now the form of du all over the du. Integral of du over u, that is ln of u plus c. So that is equivalent to negative ln of the u is cosine x plus c. This could be the other value of integral of tangent x. I said, or I've mentioned the other value. Why? Because this is not yet our final answer. Why? Recalling the property of ln. So if we have n ln of x, that is equivalent to ln of x raised to the power of n. We could place n right in at the exponent of x. So if we place this negative 1 here, ln of cosine of negative 1x plus c, from our identity, that is equivalent to secant. Recall that secant x, that is 1 over cosine x. So secant x, take the inverse, it is equivalent to secant. So this is ln of secant x plus c. So every time we're asked to solve for the integral of tangent x dx, that is equivalent to ln secant x plus c. So we have number 13, the integral of secant x dx. Notice there is no direct formula for secant x dx. We will be needing tangent in integrating this one. For the sectant, that is equivalent to the derivative of secant. So another method that we will be doing right here, we will be multiplying this with 1. But what type of value or what kind of value of 1? If we multiply this one, this term, with secant x plus tangent x, so to have a value of 1, so also with the denominator, secant x plus tangent x. Okay, so we will be having secant x, secant squared x plus secant x tangent of x all over with secant x plus tangent x, and this is dx. Now notice this is similar to correcting our algebraic term. So correcting, we will be multiplying still a value of 1 outside, but since this is a trigonometric function or an algebraic function that is not numeral, so it should be inside our integral symbol. So notice the 1 is multiplied inside the integral symbol. Now if we try to check the relationship of the numerator and denominator, if we choose the denominator as du, secant x plus tangent of x, the du, the derivative of secant, that is sec x tangent x dx, plus the derivative of tangent, that is secant squared x dx. Factoring out the dx, secant x tangent x plus secant squared x dx. Notice it is in our numerator. So, arranging, we have secant squared x plus secant x tangent x dx. So, this is now the form of du over u. The integral of du over u, that is ln of u plus c. What is again the u? It's our denominator. So, secant x plus tangent x plus c. Okay, so that's it for this